Hi everyone, welcome to BJU Today. I'm Crystal Alwell and I have with me here Dr. Mike Gray, who is a professor in the biology department. Our topic today is biofuels, and Dr. Gray has done his doctoral dissertation on biofuels. So could you just maybe start by telling us what are biofuels? What are the disadvantages, the advantages of them?
Well, from a definition standpoint, most of what we think of as fuels are in the category of fossil fuels. So those were formed by geological processes, supposedly millions of years ago, but much more recently than that. But we're talking about plant materials that have been buried and have undergone geologic kinds of processes to produce things
fossils.
to produce things like oil and coal, for instance, would be two of the major fossil fuels, and natural gas would be another one. So in contrast to that, biofuels are made by contemporary, like now, biological processes. So we don't have to look back to a resource where the geology formed the resource. There actually are ongoing processes that form these fuels. And examples of biofuels would include things like ethanol, which most people know is a gas additive. Paradoxically, natural gas is considered to be a biofuel also, so there's a crossover there because many organisms make methane gas. We'll probably talk about that a little bit later, but cows, for instance, are major emitters of methane gas. And then hydrogen would be the three biggest biofuels that, again, and hydrogen can be produced by chemical processes, but it can also be produced by biological processes. So contemporary production as opposed to a limited resource that when it's done, it's done.
Okay. So the advantage of using a biofuel versus using, say, a fossil fuel, is there less emissions from biofuels, or what's the advantage?
In general, yes, lower emissions, but if we're looking for advantages, really one of the major advantages is there's no end point. It's not like we're going to run out at some point. So these are renewable fuels, renewable sources of energy that there isn't any limit to. So although we have pretty significant fossil fuel reservoirs, there's always, whether we're talking about a political or economical perspective, this whole business of how much does gasoline cost and how long is it going to stay there and what factors are going to drive the prices up. Those would not be part of the consideration if we were talking about biofuels. And then the pollution piece is a second piece, and we have to kind of break that down depending on which biofuel we're talking about.
Okay, I've seen a lot of like car commercials or gas company commercials about doing or using algae for biofuel production. Is that less of an emission?
Well,
because I think that's part of what I'm
and that there's kind of another fork in the road there, because when we're talking about biofuels, part of this is conversion of what's called biomass, which is just the material substance of living organisms, again primarily plants, into fuels, as compared with, say, using algae, which is harnessing their ability to do photosynthesis to make a product. So perhaps a conversion mechanism that uses sunlight to make a biofuel or to make electricity to run processes is another possibility. So that's one arm. The other arm is the reality that we produce lots of biomass. I mean, every city has a sanitation department to pick up materials. And so part of this actually becomes, we've got biomass that we produce all the time. We're in an established neighborhood, for instance, and every week we generate grass clippings, leaves, branches that have come down from trees, and that's all along our street. So that kind of material, plus what goes into the regular trash, a good bit of that is plant-based material, say paper, cardboard, those kinds of things. So probably the majority of what goes into the landfill is biomass.
Okay, so this could potentially cut down on landfills.
Yes, yeah, so it's a multi-pronged kind of thing. That it's non-negotiable that we're going to be producing biomass. So what are we going to do with it? Are we just going to pile it up somewhere, or are we going to use it as a resource to make fuels?
Okay, so what are some problems with using biofuels? What are some of the things that have to be overcome before it can be commercially used?
Well, the main problems, interestingly, are economic. As long as the price point for gasoline is where it is, there's less impetus to develop biofuels. So, I mean, I've been in the business for a long time. Potentially, we could have commercialized biofuels many decades ago. It would have been realistic, I think, to think about commercial production 30 years ago of biofuels. So it's not, some aspects of this are certainly speculative and a long way from development, but others are right here, right now, if the economics were in favor of it. So the availability of fossil fuels at a price point that people are willing to pay, and an infrastructure, the oil industry, the political forces involved, all of that complicates the picture and means it's not primarily a scientific problem to get them to commercialization. It's primarily an economic issue.
So are biofuels something that a Christian can look at as maybe being a good steward of the resources God has given us? Is that kind of a Christian perspective?
I think absolutely, yeah. When you look at the language of Genesis 1, 26 to 28, where it talks about subduing the earth and having dominion over it, one person at BJU Press has actually helpfully summarized the intent of that language as saying as stewards we're supposed to maximize the usefulness of what we've been given. So stewards don't just sit on resources and protect them. Stewards actually look at what they have that's an asset that can be developed. And from my standpoint, looking at the reality of how much biomass there is on the planet, and looking at that as a resource to produce fuel is an issue of stewardship, as opposed to what historically have been fuels. And I don't know that we're going to put any kind of a moral spin on that. I drive a car that's fueled by gasoline.
Yeah.
But there is an economic aspect that's been driving that. And I don't think stewardship says we just keep going with a limited resource. We keep looking for alternatives that might be better in one way or another. And I think biofuels are clearly better in terms of air quality. Now, some parts of the U.S. don't have to worry about that, but I lived in California as a small child, and even back then the population density was sufficient that we had problems with smog, as they called it. So there's really, depending on the population density, cities are the first place where we start to have problems from the burning of fossil fuels. To the point, I think most people are aware that China has immense air pollution problems, and it's mostly because of their reliance on fossil fuels. Some of it is chemical industry, but a good bit of it is their rising standard of living means they have vehicles, and their vehicles are powered by fossil fuels. And so, we've, I think, all seen pictures of Chinese people walking around with masks on, trying to choke out enough air to keep going. So it's not like it's theoretical. It really is a population density dependent kind of thing. And if we can alleviate that problem significantly, I think it's a matter of stewardship, again, of human life in that instance, and the quality of life, as opposed to having to make compromises driven by our choices on the energy front.
Okay. Now, we mentioned that your dissertation talked about biofuels, and I probably should ask this first, but what exactly did you discuss in your dissertation? If you could maybe give a synopsis of that in plain English?
Sure. I will do my best. I think maybe it might be helpful to take a step back from that to looking at the three, what I think are the three major options for biofuels. And then it's kind of like where my dissertation comes in is going to speak to one of these that I think is actually maybe going to have its moment before too long.
Okay.
So the three biofuels that are out there right now are ethanol and methane gas, aka natural gas, and hydrogen gas. Ethanol is the least desirable of the three, and part of that is because ethanol has less energy content than gasoline, so it's not a particularly energy-rich source. And the problem historically has been that this is economics again, but the government has supported the development of ethanol and mandated its use in gasoline in a way that artificially ramps up supply and demand. And so a lot of farmland that was used to raise corn for fuel has actually been used now to raise corn for the production of ethanol, which has driven up the price of corn and taken farmland off of the market. So if we were going to improve that piece, it would be through looking at an alternative to things that contain sugars, starches, and so forth, to cellulose, which is this biomass conversion again. And there's a bit of that going on, more in Brazil and Europe than in the US, but that would involve using things like grasses and so forth to generate ethanol. So ethanol is in the supply, the energy supply already. Maybe a little bit cleaner than gasoline, but you're burning gasoline when you're burning the ethanol. Another piece that is actually in use already would be methane gas. In Greenville, for instance, we have some buses that are powered by natural gas. We've got Piedmont Natural Gas that supplies our gas, that their vehicles are powered by gas. So it's possible to take a standard internal combustion engine and convert it to natural gas use. Most of the natural gas now comes as fossil fuels, but it is potentially a fuel that could be produced by biological processes. So I mentioned cows a little while ago. Of the food that goes into a cow, about 25% of it is lost as methane gas. So the EPA actually looks at cattle as one of the major polluters in the United States.
Wow.
The major
No
producers
idea.
of methane, which is a greenhouse gas.
Right.
Maybe a little sidebar here. I think some of the ways in which we define pollution these days are not helpful. So no doubt methane is a greenhouse gas, which accentuates the warming tendencies that are there if it's not challenged by anything else to offset it. But the EPA views carbon dioxide as a greenhouse gas. And I think biblically we have to look at that differently, because in fact every living thing on the planet produces carbon dioxide, including us.
Yeah.
So we're not polluters just because of the way that we've been made. So I think there's a bit of short-sightedness in the way we define pollution. So I would take CO2 off the table, although chemists would factor it in as a pollutant. So methane gas is produced by cattle. It's actually produced by all warm-blooded animals. So there's potential there. And methane gas is produced not only by cows, it's produced in landfills. Even unintentionally, it's produced in landfills. It's produced by sewage treatment plants. And to keep it from being a hazard, they either have to capture it and purify it and market it, or they have to burn it so that they don't have explosion hazards in sewage treatment. So it's already being produced.
Right.
So those are all places where biofuels are in use. Now, what I dealt with in my dissertation was actually conversion of cellulose into hydrogen gas. So that process is also carried out in the digestive tracts of some animals. So there are microorganisms that in communities can do this kind of thing. I use paper to hydrogen gas. So it's not like, can that be done? That has been done. So hydrogen gas is actually, of all of the fuels that we've talked about, far and away the most potent fuel. And hydrogen is actually the most abundant element in the universe. So we're back to this stewardship kind of thing. One of the ways in which we can see illustrated that hydrogen gas is potent is it's used in rocket fuel.
Okay.
Yeah. So more than triple what we call the energy density of gasoline would be hydrogen gas. So it's a very potent form of energy. What's interesting to me is the potential exists to run an internal combustion engine that burns hydrogen, but I think many people have visions of, say, the Hindenburg, which had hydrogen gas as a fuel, and are leery of that. So the way hydrogen is actually being implemented, and there are programs that use hydrogen gas in vehicles on the planet. They use what are called fuel cells. What a fuel cell does is it takes hydrogen gas as an input. So there's a tank for hydrogen gas, but it's liquefied. So it fits as liquid in a tank. And you could fill up one of these vehicles about as fast as you can fill up the tank of a regular car with gasoline.
Wow.
So you put hydrogen gas in, but then it's metered into a fuel cell where it reacts with oxygen from the air. So we have H2 and we have O2. All right, and so there's a chemical reaction in there that ends up producing H2O, water, and electric current. Okay? So actually, this is a means of generating electricity for electric vehicles, and all of the major vehicle manufacturers are looking at hydrogen fuel cell powered vehicles as being the future. And what we have right now with battery electric vehicles as being an intermediate step. Because all the battery intermediate vehicles are limited in range because of the battery life. So some of them we have some kind of a hybrid situation where sometimes we're using gas and sometimes we're using electric current. So it's a compromise kind of situation. Where a fuel cell electric vehicle would actually be one where you'd stop at a filling station, you'd fill up with hydrogen, and then you would generate electric current that would run electric motors that power your car. So it's actually going to use the same technology that's already out there in electric vehicles, only it's not limited by battery life. So the range of a vehicle like that could be at least as big as a standard gasoline-powered vehicle, or actually much bigger, depending on some other variables, because it's such a potent, energy-rich kind of fuel. So what ends up happening then is these vehicles are silent, just like any electric vehicle would be, but they're not limited with battery range, and you can drive them just like a standard automobile would be driven. And the only thing they put off is water vapor.
And that's healthy, right?
Sure. And in fact, General Motors has a desert application of this that they're developing, where in the desert, not only are these vehicles very quiet and produce very little heat because there's no combustion going on, but they produce 2 gallons of water, of drinkable water, an hour.
Wow. Yeah.
So, in the desert, we're actually
Very
looking
helpful.
at all assets there. So when I say future, some people feel like, and really it's an economic question again. It's not a science question primarily. So California, if I lived in California still, I would have a hydrogen fuel cell powered vehicle. They're available for lease in hydrogen because actually Arnold Schwarzenegger, when he was governor out there, had an initiative to produce a hydrogen highway, he calls it, that the state of California has invested in. So you can get a lease on a Toyota or a Honda or a Hyundai out there. And those three manufacturers are actually working with all of the other major manufacturers. So BMW and General Motors and Ford and Nissan, et cetera. They're all involved with one of these conglomerates. So the main issue has been where are these filling stations going to be and who's going to be doing it. And then the second issue is where does the hydrogen come from? Well, so the state has made it as economically underwritten producing hydrogen filling stations, much like we're doing for charging stations for battery vehicles. And they're putting these in place. So it's now possible to drive from one end of California to another with a hydrogen fuel cell powered vehicle. And they're adding more stations. So I think by the end of the year, they're supposed to have like 80 stations that are strategically placed around the state. So there are thousands of vehicles there that are on lease. The bigger move is only a couple years out. The Olympics are going to be back in Tokyo.
Right.
So the last Olympics, many years, decades ago, the heritage of that Olympics is the bullet train.
Right.
Which I've ridden on over in Japan. And it's impressive. The mayor of Tokyo views this Olympics, the heritage is going to be hydrogen-powered vehicles.
Interesting.
So their goal is that everybody who's ferried around from one place to another on buses and in cars is going to be going in hydrogen-powered vehicles over in Japan. So it's not as futuristic as it sounds. And the main issue then is going to be these hydrogen filling stations. Well, that kind of brings us to the last piece of this, which is where's the hydrogen going to come from? And unfortunately, the processes that are being used right now are kind of quick and dirty kinds of processes. Okay. So the easiest but dirtiest way to produce hydrogen gas is to take methane gas apart. Methane gas is CH4, so you can get two H2s out of it and have some carbon left over. So you really have a refinery. It's about 50% cleaner than an oil refinery, but it's still a refinery. Yeah. You can get hydrogen gas from electrical current being applied in a certain way to water. So you can get H2 out of H2O. And that's more energy intensive when I say electric current than what's behind that electric current becomes the issue. Or the third way is the way that I worked on in my research, which is to biologically produce hydrogen gas. And I think the optimal way to do that is to address the biomass issue, that's an issue anyway, and convert it into something we want, which is hydrogen as a fuel.
All right, well, thank you very much for taking the time to talk to us today. It was
You're
really
welcome.
interesting. Be sure to check out more on BJU Today, and we'll see you next time.